Hi, my name is Tim, and today I'm going to present you our paper accepted at WACV 2024 titled SciOL and MuLMS-Img, introducing a large-scale multimodal scientific dataset and models for image-text tasks in the scientific domain. So why do we even need scientific image-text models? In research and development, we spend a large fraction of the time by reviewing scientific articles to keep up with state-of-the-art results. However, this becomes increasingly harder as the number of scientific publications grows exponentially and doubles nearly every 10 years. Most systems today that aid information retrieval are limited to textual data. However, figures play a central role in scientific publications as they often show important information, including, for example, experimental outcomes. It would therefore be useful to have systems that allow finding relevant figures and thereby publications given natural language descriptions. Existing image retrieval systems are mostly trained on images from non-scientific domains, which are distinctly different from those in scientific fields. There are only few scientific image retrieval models, which however only focus on a single scientific domain, such as biomedical and life sciences or computer science. This bias towards some scientific domains is in part due to the lack of training data. To close this gap, we present and release two novel datasets in this work. We first present openly licensed scientific publications, or in short, SciOL. This is a large-scale, automatically derived dataset consisting of permissively licensed English scientific publications from a diverse range of scientific domains and converted into semi-structured data. Second, we present MuLMS-Img, short for the Multilayer Material Science Image Corpus. It consists of figures extracted from material science publications with high-quality manual annotations for various image text tasks. SciOL consists of about 2.75 million publications indexed by the Directory of Open Access Journals and PubMed Central, filtered for permissive licenses. It contains nearly 15 billion tokens, automatically structured into semantic categories, such as the title, authors list, abstract, or the body text. In addition, we extract over 18 million figures and match them to their captions with an optimal matching algorithm. Compared to other scientific image text datasets, SciOL covers a broad variety of scientific fields, including material science, mathematics, physics, computer science, and economics. It is over 40 times larger than SciCap and about 1.2 times the size of PMC15M, which covers mostly biomedical publications. SciOL is, to the best of our knowledge, the largest collection of openly licensed text and image text data. MuLMS-Img is an extension to the multi-layer material science corpus, which consists of 50 scientific publications annotated for various NLP tasks. We extract a total of 1,075 figures from the same 50 publications and manually create the figure type annotations and over 13,700 annotations for the text positions, the text content, and the role of the text within the figure. In addition, we task an expert from the material science domain to write brief search-style retrieval queries for the images in our test split. The style of these queries typically deviates from the descriptive and wordy nature of captions and should allow us to evaluate the text-to-image retrieval in a real-world setting. We use these two novel datasets to construct SciOL COCA, our scientific image text retrieval model. It is based on the recently presented COCA architecture, which combines representation learning with autoregressive captioning. To adapt it to the scientific domain, we select a large input resolution and small patch size to attend to fine-grained features and increase the maximum text sequence length compared to the non-scientific domain to model the on average longer scientific captions. We trained this model on about 15 million figure caption pairs from SciOL and split the remaining 15% into a validation and a separate test set. This yields our SciOL Cooker base model. One of our research questions here is how well SciOL Cooker, which is based on the Cooker architecture designed for the non-scientific domain, can implicitly understand text that is present in scientific figures. Therefore, we use the text annotations from MuLMS-Img to fine-tune a scientific OCR model. This allows us to explicitly extract text from the image and use it as additional feature for the figure representations. We embed both the OCR text as well as the caption with SciOL Cooker and aggregate them together with the pixel-based representation into a joint multimodal figure representation. We evaluate the image-to-text retrieval performance of our models on the MuLMS-Img text queries. Since MuLMS-Img is composed of comparably few samples, we add 20% of the figures from the SciOL test split as negative samples. We can see that training on SciOL largely improves performance compared to the non-scientific Cooker and existing scientific image text models. By adding textual features, we can observe a large increase by up to 50% in the retrieval performance on the MuLMS-Img queries. This increase comes from combining visual and text features, since only using text features as input performs similar or below our SciOL Cooker base model. Our human evaluation of the top 5 retrieved figures confirms the previous observations that adding textual features highly improves retrieval performance in the material science domain. In addition to evaluating retrieval performance, we also test how well our base SciOL Cooker can be transferred to other scientific image text tasks without further fine-tuning. Here we treat figure classification basically as image-to-text retrieval with the class names as text queries. On both MuLMS-Img and UBPMC, which is a corpus of chart figures from the biomedical domain, we can see a large positive effect of training on our SciOL dataset. Similar observations can be made for figure captioning, where our SciOL Cooker outperforms the base Cooker significantly, indicating a good adaptation of the domain-specific language. To sum it up, we have presented 2 novel datasets in this work. A large-scale text and image text corpus constructed from openly licensed scientific publications, as well as a high-quality dataset from the material science domain, manually annotated for image text tasks. In addition, we introduced SciOL Cooker and showed that explicitly integrating textual information from figures increases retrieval performance considerably. SciOL Cooker also shows good transfer performance on image text tasks in the material science domain without further fine-tuning. Potential areas of future work could include using the text data from SciOL as another feature for representation learning, or to explicitly integrate the OCR text during training time. Thank you for your attention, and if you're interested in our datasets, you can find them linked in our repository.